Hello everyone, I'm Bingjo. Welcome back to another video. So in this video, we're going to be looking at a lot of properties of circles. So it's like the area, the perimeter, sector area, and so on. So let's write down the agenda for today. Okay, so we are going to be looking at number one. Okay, anyway, number one, we're going to be looking at the circumference of circle. Number two, it will be the area of circle. Number three, after that, we'll be looking at the arc length, all right, of a sector. And number four, we'll be looking at the area of sector. All right, so this is gonna be a short video, I believe. So let's jump into our first agenda for today. So first thing, before we're gonna do any calculations on circles, there's one thing that I'm pretty sure all of you had heard before, which is pi. So what is pi? Pi, I googled that by the way. The definition of pi is the ratio of circumference, ratio of circumference of a circle to its diameter. All right. Don't actually totally understand that, but just remember, if you see any calculations about circles, about spheres, then you you're gonna expect to see pi in somewhere. All right, so pi is an irrational number. All right, irrational number means that you cannot um, express it in terms of fraction. All right, however, you might ask, right, I actually saw someone define, right, someone defined pi as pi is equals to 22/7. Right, so since you say pi is an irrational number, why can we express pi in 22/7? And something to actually take note here, this is not equals, all right? This is actually approximately 22/7 because the pi is actually still undefined now. I mean, it's not totally written down. It's like uh it's not ended yet, right? Someone says that it's still going on the decimal places. So pi sometimes, according to the question, might ask you to approximate pi as 22/7, or you can express it in equals to pi 3.1415 something, I guess, 15 something, which in turns 3.142. All right, so 3.142, 3.14, 22/7 are the more usual ones that we're going to use in calculations, depending on if your question states that if you need to use any of the specific one. But usually in mathematics, I remember this one is the one that they usually want you to use. All right, and maybe this one. These two are the more popular ones. All right, so this is an important one, pi, because you're going to see a lot of pies. All right, so yeah, as you have listened to the name pi, right? So how do you write it? It's pi, pi. All right, it's some kind of a language. Forgot which one is that. I think it's Greek. I'm not sure, but it's literally like a pie, when it's the pie is literally just circle in shape and so on. Yeah, so that's why it's used to calculate a lot of calculations in circles. All right, so first thing we're going to be looking at the circumference of a pie. So how do you look at the circumference of pi? Circumference of pi, sorry, circumference of circle. All right, so number one, you have a circle right here. Oh dear, this is just ugly. I remember there's a shape thing right here. Yeah, this one. Okay, this one. Let's go. Okay, so the exterior length of this circle. So the outer layer, this thing right here, I'm just bad at drawing circles in this pad anyways. Okay, just give me one last try. Okay, I'm gonna do it slowly, nice and slow. Okay, not too good, but it's the best. Right, this outer layer, this length is called the circumference. All right, so it's literally the perimeter of a circle. All right, so the formula is equals to 2 pi r, or equals to pi d, where r is equals to radius and d is equals to diameter. All right, which is equals to 2r. Both of these are equivalent. So it depends on which one you use, but usually we use 2 pi r. All right, so if you're asking for proof, there should be a proof somewhere in Google, but I'm not doing it here because I don't know either. So you're just going to remember it's 2 pi r. All right, you're going to see a lot of 2's, a lot of pi, and a lot of r's in all the formulas. All right, and number 2, we have in the middle here, let's change to this color. This part here is the area. All right, so the area is the region inside the shape, remember from the previous video, right? So this part right here is the area. Okay, so you're gonna see what is the area of a circle. So the area is in turn, in fact, the area is pi r squared. Just that simple. All right, so if the question gives you in terms of d, let's say that they say the diameter of a circle is 4 cm. So you might want to divide it by 2, so the radius is 2 cm and sub it into this. Or since r is equals to d over 2, therefore it is equivalent to pi d squared over 4. All right, both of these are equivalent, so you can change it in the way that actually ease you when you calculate calculate the circle. All right, so we have done the first two agenda really quick, as I said. All right, we have done the circumference, area of circle. Now is the sector. All right, so right here we have the sector. Let me draw a sector right real quick. Okay, so a sector is just a part divided in the circle. All right, so first thing I'm going to draw where's the shape? Okay, I'm gonna draw a circle, right? A big one, a real big one. Okay, this will be good. Next, there's enough space, I believe. All right, let's move this up a bit. Okay, so this is a circle, and then this is the midpoint. Okay, I'm gonna change to this color right here, midpoint. So a circle, the whole circle is pi r squared, all right, the area inside. So let's say you bought a pizza, okay, and then you cut it into some equal sectors, all right. So let's say this is one part of the pizza where you have theta right here, all right. So this is the angle that you cut from this circle, okay. So from the previous two videos, I remember when I introduced to you the names and the properties of circle. So this this part right here, is the arc length. All right, so there's a formula for arc length. All right, and I'm gonna write it down there after that. But just to introduce to you, this is the using a different color. This is the sector. All right, and then we have something like if we divide this is a segment. All right, so just a little bit, sector includes this and this. All right, but segment is just the area on the top. Okay, so now we are gonna calculate the arc length. Okay, maybe I'll just name this as arc. All right, and then down here we are gonna look for arc length. And there's nothing to memorize actually for this one because arc length is equals to, as you can see from the top here, it is just one part out of the whole circle. All right, so if you can derive from the circumference of a circle, then you might have a easier life. All right, so first thing, you can say the arc length is equals to the circumference of the circle multiply with theta over 360, because theta is given to you, or you need to find it in some other way. Maybe they give you the area or sector and you can find theta from there. Theta, you know what's theta, and then you know the whole circle is made out of 360 degrees. All right, so this is just the formula for arc length, which in turns you will get this to be equals to 2 pi r multiply with theta over 360 degrees, right? It's just that simple, all right? So to calculate arc length, this is the way, all right? And it's easy because it's just some fraction of the whole circle, all right? You get it, how to see it, so you don't need to actually memorize it. Number 2, we have the area of sector. And it's the same concept as the one above because you can find it from area of circle multiply with theta over 360 degrees. All right, theta in terms of degrees, and just write it down. Okay, it's just that easy. So it's equals to, oh, it's a different one, pi r square multiply with theta over 360 degrees, right? It's just that simple. Okay, so there's nothing to actually memorize in this. And then the area of segment. Okay, so this segment thing right here is a little bit tricky that I'm gonna show it in the next slide here. So let's draw. Okay, one last try. Okay, this will do. Okay, so this looks like an ice cream, isn't it? By the way, then this is segment, and this whole thing is sector. Okay, so you can actually derive the formula of a segment by just saying the area of segment is equals to area of sector minus the area of triangle. All right, so where did the area of triangle come from? Okay, so this is the area of the triangle. This one, this part right here is the triangle. Okay, and there are a lot of ways to find the triangle because you know that this is an isosceles triangle. These two are the radius, right? So since it's a radius, both of these must have the same length. So when you have theta right here, you can divide this, this one. You can divide this by half, all right? So this is in turn theta over 2. Then you can find h, okay? After you find h, and then you can use Pythagoras theorem or even use 1 over 2 AB sine c, where we're gonna see it in the trigonometry video later on. So by using Pythagoras theorem, you know the r, you get the h, you find this one, the half of the chord here. Then you can use base multiply with height divided by 2, then you get the area of triangle, and therefore you get the area of segment. All right, you can try it out. And it's very hard to actually write it down in terms of unknowns. but let's try it. Okay, so the area of sector is equals to theta over 360 degrees multiply with pi r square. Okay, and this whole thing you need to minus the area of a triangle. So let's try this one right here. So you can either area of triangle can be 1 over 2 AB sine C, which is 1 over 2 r square sine theta. All right, we will see it later on. Or equals to theta over 360 degrees multiplied with pi r square minus, so from the top here, you can get h is equals to r cos theta over 2. All right, and you will find it somewhere. You can try it if you know the trigonometry rules. All right, you still need the trigonometry to find h. All right, so the Casotois stuff. All right, and after you found h and you know r, you can get this chord length right here. Let's name it x. X is this part right here. Okay, so x squared is equals to r squared minus h squared. So x is equals to x r squared minus h squared. All right. After you get the x, you need the whole chord base as the base. So it's 2 multiplied with x. So minus 1 over 2. Sorry, not this. The 2x. So it's 2 r squared minus h squared, the whole thing multiplied with height divided by 2, which gives you after you simplify, you will get something like this. All right, r squared minus h squared. So r squared minus h squared. All right, it's just that simple, given that you know the trigonometry rules. Yeah, so just to double check, the area of triangle, something just looks wrong. I'm gonna double check on this, but I'm gonna bring it back when we study the trigonometry later on. So I'm not gonna show this right now because it looks a bit sussy for me, and I'm gonna erase this too. Okay, so for now, all you need to know is to how to find the area of segment. So the concept is using the area of sector minus the area of triangle, and that's all. All right, so for this video right here, we're gonna end it because it's just the agenda for this video. So yeah, to recap, I had shared on how to find the circumference and the area of circle, and then after that, the arc length and the area of a sector. And that's all for this video. Thank you for watching.